Hello everyone, welcome back to my YouTube channel. So today I'm going to solve day 19 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1625. Lexicographically, smallest string after applying operations. So lexicographically means a dictionary order, right? So in dictionary you see first A letter words, then B letter words, right? Something like this, then C letter words, right? And in A also you see words like this, A, then A, B, then A, C, like this, right? In this order. So let's read the problem statement. You are given a string S of even length consisting of digits from 0 to 9 and two integers A and B. You can apply either of the following two operations any number of times and in any order on S. So what are those two operations? First is add A to all the odd indices of S, zero indexed, right? So it's not what zero indexed string, right? So we have to start the indexing from 0, right? And then we can add A to all the odd indices of S. So for example, digits post 9 are cycled back to 0. Okay, this is also given, right? So we can only use this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And after 9, we are again going to start from 0, 1, 2, 3, like this. For example, if you see this string S is equal to 3, 4, 5, 6. So here if I just give the indexing, so 0 index means 0 starting from 0, 1, 2, and then 3. So here A is equal to 5. So here and here we need to add A, right? So 4 plus 5 is equal to 9, right? So here if you see in the output, here we are getting 9, and here 3 and here 3, no change in 0 in even indexes, right? Here 5 and here also 5, here 6. So 6 plus 5 is equal to 11, right? But 11 we can't use, right? 11 we can't use, right? So since this is nothing but a cyclic order, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then again 0, 1, 2. Okay, so here we are getting 9, right? So here if I do 9 modulus with how many total number of digits? Total 10, right? 9 modulus with 10, so it is nothing but 9 only. Same way here 11 modulus with 10, if I do, I will get 1 only, right? So I have to just do the modulus with the total number of digits that I can use, right? Then I will be able to perform the cycle, right? So here 9 modulus with 10 is 9, so 9. Here 6 plus 5, 11. 11 modulus with 10 is nothing but 1, so I'm writing 1 here, right? Same way here, if you have 8, right? If you are at 8, right? And if I told you to add 6 to it, so you are going to get 14. So 14, if you do the modulus with the 10, right? So you are going to get 4. So see, 6 you are doing, right? So 1, then 2, 3, 4, 5, and 6, right? That's it. So we have to just do the modulus with that, okay? And we have to return the lexicographically smallest string that you can obtain by applying the above operations any number of times on S, right? The second operation is this: rotate S to the right by B positions. For example, if S is equal to 3, 4, 5, 6 and B is equal to 1, so all the things we have to rotate by 1, right? To the right. So 6 is going to come first, and then 3, 4, 5, 6. 3, 4, 5, right? So here this is what we are getting: 6, 3, 4, 5, right? So S is equal to 3, 4, 5, 6, right? S is equal to 3, 4, 5, 6, right? And B is equal to 1. So you have to just rotate now. So 6 is going to come first, then 3 is going to move to the next position, 4 is going to move to next position, 5 is going to move to the next position, right? You are getting 6, 3, 4, 5, right? 6, 3, 4, 5. Or you can also write it like this. You can write it like this, but there is one way in code. What we can do: B value is 1, right? So B value is 1. So first of all, what is the total length of this? Total length of this is nothing but 4, right? In this 4, if you subtract the value of 1, what you are going to get? You are going to get 3. So that is nothing but n minus b, right? 4 minus b, b value is 1, right? So you are going to get 3, right? So here if I just give the indexing here, 0, 1, 2, 3, right? So if I write the substring starting from index 3, so that simply means 6 only, right? In this 6, right, this is one substring, right, starting from n minus b, and here I will add one more substring which is starting from 0, right, until n minus b. So 0 until n minus b, right? So this is exclusive in substring function of string. This is exclusive, we don't add this. So 0, 3 means 0 to 2. So 0 to we have 3, 4, 5, right? So that's what 6, 3, 4, 5, right? This is what you can do, right? So same way here, if you have string like this 3, 4, 5, 6, And if I say b is equal to 2, so b is equal to 2 means first you have to write the last 2 and then you have to add the remaining things. So this is what you are going to get after rotating the string 2 times. That's it, right? Okay, so we will use this function, right? So this is nothing but substring function, substring n minus b plus substring of starting from 0 to n minus b. Okay, this function we are going to use. All right, clear? So a string A is lexicographically smaller than string B of the same length if in the first position where A and B differ, string A has a letter that appears earlier in the alphabet from the corresponding letter in B. For example, 0158 is lexicographically smaller than 0190, right? 0, 0 same, 1, 1 same, 5, 5 is smaller than 9. So that simply means that this is smaller. Because the first position that differ is at the third letter and 5 comes before 9. That's it. Okay, so dictionary order you can say. And everyone knows about dictionary, right? Okay, and these are the constants. So s dot length from 2 to 100, small constant size. S dot length is even, okay, and s consists of digits from 0 to 9 only, right? And a value is also from 1 to 9 and b is from 1 to s dot length minus 1. Okay, clear? So these are the constants. And here if you see this example number 1, so we have 5525, a is equal to 9, b is equal to 2, right? So we can apply the following operation. It is saying first it is taking the same string, then it is rotating by 2. So by 2, okay, this b is nothing but for rotate, and this a is 9 for add odd indices, right? This is the meaning of this. So rotate by 2, so we are going to get this 2 5 and then 5 5, then add 9. So here add odd, 5 plus 9 is nothing but 14, 14 modulus with 10 is nothing but 4, so we are getting 4 here, same way 4, right? Then again it is adding, so 4 plus 9 is 13, 13 modulus with 10 3, so we are getting something like this. Then it is rotating 5 3 2 3, then it is again adding 5 2 2 2, it is again adding 5 1 1 odd on this, right? And after that it is rotating, so we are getting this, adding, then we are getting this. So there is no way to obtain a string that is lexicographically smaller than the 2050, right? And then we are returning this as our output. Okay, so we have to just apply these operations, rotate, add, how many number times, right? You can apply this operation many number of times, right? And in the end you have to return the smallest, right? Okay, see this example number 3. So here 0 0 1 1, a is equal to 4, b is equal to 2. So here 0 0 and 1 1, so there are no sequence of operations that will give us a lexicographically smaller string than this. Okay, so you can try to apply all these operations, but you will never get any smaller string than this, right? Same way here in this example number 2, s is equal to 74 and a is equal to 5 and b is equal to 1, right? Let's see how I'm going to solve this problem now. Okay, so we have 74, right? This is what I have, right? Let's say this is nothing but my level 0. Okay, this is what we have initially. So I can do two things, right? In my string, two things I can do. One is, this is odd index, this is even index, this is odd index. So here in this problem, a is equal to 5, right? So I can add 5. So I can add 5 to the odd indices like this. I will get this, right? If I add, or I can rotate it with the b is equal to 1. So if I rotate, I will get 47, right? This is what I can get, this is what I can do, right? So rotate, right, b value, and here add a value, right, or indices, right? This is what I can get, right? So this is your level 1, right? Okay, these two things you can get. Now again, here also you have two options, right? You can add a at odd indices, right? And you can rotate. So if you rotate, you are going to get 97, right? And if you add a at odd indices, so 9 plus what is a value? A value is 5. So 9 plus 5 is 14. So 4, right? You are going to get 4. 74, right? You are going to get 4. Okay. So here this is 74 and here this is 74. You are again getting the same state, right? Here if you notice one thing, right? 9 plus 5 44, 4 plus 5 9, and here 9 plus 5 same state now. So I have already seen this state here. I don't want to repeat this cycle, right? So I will keep track of the visited states, I can say. So I have already seen this 74 in the past, so I can create one set. In set I will just add all these states. 74 I have seen, 79 I have seen, 47 I have seen here, 97 I have seen here. Okay, right? And same way here also, you have two ways, right? Add a at odd indices and rotate. So if you add 8 7 plus 5 12, that's 2 you're going to get, and here you're getting 74 again, right? So stop it now. Here also you can stop, here also you can stop. So right now I have these two, okay, 42. All right, so here also if you see, you have two ways. You can add a and you can rotate, right? So if you rotate, you are going to get 24, right? And if you add, you are going to get 47, right? 47 you have already seen in the past here, right? 24 for very first time you are seeing it added here, right? Here in this case you're saying the statement, if you see output is saying 24. 24 is the best, right? So we know that we are getting 24 here, right? Okay, same way here also you have choices: add, rotate. Okay, all these choices you have, right? So this level, this is one level, this is one level, different levels you are seeing here step by step. Okay, and from all these levels we are deriving the different variations, right? And on those variations again we are doing some number of operations and all that stuff, right? So here if you notice one thing, we have 74, right? So this is a odd place, right? Odd place. So in this odd place I can get 5, I can get 6, sometime I can get 7, I can get 8, I can get 9, I can get 0, I can get 1, right? 2, I can get 3, right? All these things I can get if I just change this place. But there will be time when I'm again going to get a 4, right? Because only 0 to 9 we have, right? That is nothing but total 10 digits we have, right? So again I don't need to calculate, right? Again I don't need to calculate. Same way, only odd indices we can change, but here if I just rotate it with 1, right? So we have 74, right? Initially string, right? There are only two variations, right? 74 or 47 as b is equal to 1, right? So in worst case scenario only two variations are there, right? Two variations are there. Okay, and I can say in worst case scenario I have total uh, n number of variations, right? N is nothing but the length of this string. So in worst case scenario I have total n number of variations. In those variations only I have to do the rotations, right? And then I have to do level by level traversal, right? So 74, I have 74 only, 47, and this is one level. So in this also I can derive few more levels like this, right? Like add, rotate, all that stuff. Okay, all that stuff. So here if we have 47, so let's say now at this point I'm going to do I can get 8 here, I can get 9, get 0, 1, 2, 3, 4, 5, 6, then again cycle will repeat. Okay, here also. So here we have 10 different variations. Here also we have 10 different variations of this, right? This particular can form a combination with this, okay, like this, right? Then this also can form a combination with this, right? So 10 into 10, and overall 74 and 47 only two we are checking. So this is going to be your worst case time complexity for this particular example, right? 2 into 200 you can say directly, right? So 2 is nothing but n, and this is nothing but 10, and 10 is nothing but the at odd places how many different type of combination I get, right? So if I get 74, then from that if I do the rotate, right, and again if I do the add, right, so I may get here 47, or I can get 48, I get 49, I get 40, I get 41. Okay, different type of things are possible here. So that's what we need to do, right? So that is why here if you see constant size is very small, right, of n into 10 square, right? This is what you are getting. So n is also very small, right? Only 100. So definitely we can solve this problem in this time complexity. So how I'm going to do that, right? So if you see the same example, 74 we have, right? So I'm going to create one set, right? In this set I'm going to add 74, and I'm going to create one queue. Okay, level by level I'm going to traverse. So level order traverse is nothing but a BFS approach, right? So in the queue I'm going to add this 74, right? Now in the queue I have added 74. Now I'm going to run one loop while my queue is not empty. So while my queue is not empty, queue is not empty, I'm going to run this loop, right? So in this I'm going to call this element 74, right? Now here I have 74, right? So first if I add a to all the odd indices, I'm going to get what, 79, right? So 79 I haven't seen it yet, I haven't seen it yet in my set. So in the set I'm going to add 79, and then if I haven't seen it in the set, then only after that I'm going to add it in my queue. So I'm going to add 79 in the queue, right? And what is the operation 2 that I can do here? I can rotate it by b. B is 1 in my case, so I'm going to get 47. 47 I haven't seen in set. I'm going to add 47 here, like this, right? So this is done, and side by side I'm going to keep track of the minimum value as of now. So minimum value as of now is 47, right? 74, 79%, minimum is 47 as of now, right? Okay. Or you can do one thing, doing instead of this, you can say here as of now minimum is 74, because we just poll this element as of now. Now I'm going to poll the next element, 79. 79 is smaller than 74? No, right? So 79, for 79 I'm going to see 79. If I add 5 here, I will get 40. And here 97. 74 I've already seen, right? 97 I haven't seen. I'm going to add it in set, and I'm going to add 97. Okay. Then next time, again my queue is not empty, so I'm going to poll 47. 47 is minimum, right? I'm going to keep say that 47 is a minimum. Now for 47, I have to check the possibilities. So if I rotate 74, and if I add 5, 7 plus 5 is 12, so I'm going to get 42. So 42 I haven't seen it, so I'm going to add 42 here, right? This is done. Now next time I'm going to poll this 97. Okay, so 97 is not smaller, so I'm not going to do anything here. And here 79 I can get, 79 is already there, and 7 plus 5, 12, 92. 92 I'm going to get, so I'm going to add 92 here. Okay, and here I'm going to add 92, right? So we have now 42 and 92, right? And next time I'm going to pull this 42. 42 is smaller than 47, so I'm going to add 42 here. So for 42 I have to, okay, one is 24 and one is 47. 47 I already seen. For 24 I haven't seen yet, so 24 I'm going to add, and here I'm going to add 24. Done. Now after that I'm going to call 92. So 92 here is not smaller than 47. 47, okay, so 92 we can get 29, and 95 here 5 of 7, 97. So 97 is already there, and 29 is not there, so I'm going to add 29. Okay, and here I'm going to add 29. Same way, now you have to move this 24. Okay, so 24 is smaller than your previous one, so here I'm going to remove this, and then 24 you have to add 42. 42 is already there, and if you add 5 here, so you are going to get 29. 29 is there, yes, it's there, so that's it. So now from 29 you have to see, so from 29 you have two options, right? One is 92. 92 is already there, and 29 plus 5, so 14. Okay, so 24 is already there, yes, it's already there, so your queue becomes empty. So in the end minimum is 24, like this you have to solve. Okay, like this. So we are going to check all the different possibilities, all the different combinations, permutations, right? We will check all the strings that we can form. Okay, and when my queue becomes empty, then whatever the minimum is, I will just simply return that. That's it. Let's write the code. Very simple, nothing complex. Code is going to be very small. Okay, whatever I explained, I'm going to do the same thing. So here set string c is equal to new hash set, and here I'm going to write queue, and in the queue I'm just going to add the strings, right? And here queue is nothing but new linked list. Okay, and in the queue first time I'm going to offer the current string that I have, and in the set also I'm going to add this particular string s, right? And then I have to return answer in a string format, right? Final output. So here in the answer initially we'll just store this s, and my n is nothing but the s dot length value. Okay, this is string, so write like this, and here we have to just simply run one while loop while my queue is not empty. Okay, so here I am going to poll the current string, so queue dot poll. So after polling this, I'm going to update the smallest. So here I'm writing update smallest, and here I'm going to write if cur dot compare to answer. All right, and compare to, it'll just check like dictionary order, right? So if it comes out to be smaller, right, negative value less than 0, then I'm going to update the answer as equal to cur. Okay, and then I'm just going to apply operation 1, that is nothing but add a to all odd indices, right? So here char array, here cur to char array, right? and then after that I'm going to run one loop. Int I is equal to 1, I is less than n, and here I will do I is equal to I plus 2, right? So I can write it like this, right? And here I have to just update my array of I as here I will write array of I, right? And in this array of I value, if I subtract 0 from it, right, I will get a number, right? In that I will just add the value of a, right? And once I add all this, right, so I will get one number, right? As of now I will just do the modulus with the 10 of this particular number, and once I do this, okay, once I do this I have to convert it back to char. So I have to write it like this here, and here this complete I will write here char, okay? So char, and here this complete ends here, and that's it. Okay, so I'm converting it to char again, and then here I'm going to check if this I'm going to create one variable string add op is equal to new string, and here I'm just going to add this particular array, right? I'm will form a string, and I'm going to check if I have already seen this string in the past or not. If seen dot add this add op, okay, add operation. All right, here I will just do q dot offer. In the queue I'm just going to add this add op, okay? This is done, and here this a should be small, right? So this is one operation, and what is my operation 2? Operation 2 is nothing but rotate by b, rotate right by b, right? And here string rotate operation. So this I have already told you in the starting itself, cur dot substring, that method, right? Last elements we have to pick n minus b, then from start, right? That method, cur dot substring 0 to n minus b, and here same thing, this one, right? But we have to just change it. We have to just write rotate op here instead of add op. We have to write rotate op, and in the end, once my queue becomes empty and we check all the strings, we can simply return the answer, right? And we are updating answer here. All right, let's run it and see if the code should try to fix that. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. We'll see you in the next video. Thank you. Bye bye.